Taking safety for granted and the carelessness in the shop is probably the biggest cause of safety problems that we have.
I was spraying something and it didn't go where I was spraying it, and it backed up, got me in the eye.
I am very particular about the shop. I like a clean shop, and I expect that my employees should keep it that way.
I had some gas laying on the intake manifold. I blew it off with air. It went across the spark plug wire, and the whole car had caught on fire.
It's very, very important to be safe and do the right things, and if you're not sure, ask.
Working safely in the automotive shop. Working safely on automotive systems. When working on any area of the automobile, it's important to understand the proper use of safety procedures. There are numerous kinds of chemicals and tools that are a danger to you physically. The proper techniques for handling them will keep you and others out of harm. In the following program, you'll be introduced to safety procedures used while working in and around various automotive systems.
Electric cooling fans will run whenever the engine temperature is high enough. This means that even when the engine is turned off and the key is removed from the ignition, the fan will be able to start. Working on belts, fans, or water pumps can be dangerous. Anything can get caught in the belt, pulling you toward the engine and fan very rapidly.
When working with the battery, keep in mind that electrolyte is a mixture of water and sulfuric acid, producing a voltage that will power the battery. Electrolyte is also explosive and should be kept away from matches and flame. Contact with your eyes can cause serious damage. Safety glasses must always be worn. If electrolyte comes in contact with your skin, wash it off immediately with soap and water. It can burn.
Before working on the battery or any other part of the car that requires power from the battery, you'll need to disconnect it. First, disconnect the negative or ground cable side of the battery. This will eliminate any voltage from traveling to the areas you'll be working on. Accidentally touching sheet metal with a tool at this time won't give you a spark since both are negative. However, if you disconnect the positive side of the terminal first and touch sheet metal connected to the negative side, you will get an arc. Crossing the terminal with a tool while it's still hooked up will also give you a spark, so be careful when handling tools.
There were a bunch of wrenches there, and I was busy working under the car, and one of the wrenches slipped and went across the two terminals on the top of the battery, a direct short. It caused an explosion that luckily all 6 caps blew out and hit the ceiling of the shop. I was lucky in that they blew up instead of them holding tight, and then the case would have exploded and hit me with acid all across the face.
When working on a car with a computer, it's possible to back up the computer memory with a 9-volt battery. To begin, take a regular 9-volt battery and plug it into the cigarette lighter, using an adapter to connect the battery to the lighter. This will serve as your backup system.
When charging the car battery, you could be charging it while it's in or out of the car.
I was working in an engine compartment with a car that had a low battery, which I was in a hurry, and we were trying to charge the battery up on a fast charge. A high rate of charge is what it was. And I didn't have goggles on or anything, and the battery blew up.
When out of the car, place the battery on a level surface and attach the positive cable to the positive post and the negative cable to the negative post. Before plugging the charger into the wall outlet, be sure it's in the off position. If this is not done, the battery could explode when the charger is plugged in. Next, check the chart on the battery charger for the proper charging rate. Once found, set the rate and the timer. Don't smoke or cause any sparks around the battery while it's being charged. The gas given off by the battery is hydrogen and highly explosive. If left on the charger too long, the battery will produce smoke and a strong odor. Be sure the area is well ventilated and always follow the warning labels printed on the battery.
When servicing the starter motor, you'll probably need to get under the vehicle to remove it. Disconnect the negative battery cable first to prevent the car from starting. Once you've removed the starter motor, you can prepare to bench test it. To bench test the starter motor, first attach the battery cable from the positive side of the battery to the positive terminal on the starter motor. Attach the other cable from the negative side of the battery to the starter motor. Then attach the remote starter leads to the positive battery terminal and solenoid terminal.
Ignition systems are capable of putting out more than 40,000 volts. Handle coil or spark plug wires with caution. If possible, allow the engine to cool down before removing the spark plug wires or spark plugs. This will lessen your chances of being burned on the exhaust manifold. If your car uses a distributor that has been removed or replaced, it's possible the ignition timing could be off, creating an engine backfire. When ready to crank over the engine, keep your face out of the way. A ball of flame can come out of the carburetor or throttle body, resulting in injury. If the electrical problem is causing fuses to blow, then somewhere in the circuit there's a short to ground. Use a fuse jumper wire or circuit breaker to find the problem. Be sure the breaker has the same amperage rating as the circuit. Circuit breakers allow you to work on the problem circuit without causing any other damage.
When beginning to work with the radiator, it's a good idea to allow the engine to cool. The radiator cap is pressurized, enabling the coolant to run at a higher temperature without boiling, approximately 235 degrees Fahrenheit. Made up of antifreeze and water, the steam will spray out of the radiator like a geyser, burning you if in the way. Once the engine is cool, turn the cap slowly to the first notch, releasing the pressure. Once released, turn the cap the rest of the way until it comes off.
When servicing the fuel system, any remaining fuel in the lines will need to be released.
While I was busy talking with the customer, one of the other employees got in the car to move it. I hadn't disabled the ignition or the battery. We normally now just disconnect the battery. And he cranked the engine over, and it was an open fuel line, and of course it caught fire. It was a big deal. Nobody got hurt, but it almost destroyed the whole car.
I was blowing through the fuel line with compressed air to get rid of any dirt that was in the line. Well, as I blew through the line, the air went through the fuel line and hit the drop light. It knocked the drop light off the hook and it landed on the floor. The bulb exploded and ignited the fuel that was dripping on the floor, but it ignited the trail of fuel that was coming out of the gas tank.
There are several methods of depressurizing the fuel system. You could disconnect the fuel pump relay or pump fuse and crank the engine, or use a fuel line pressure gauge to release the pressure. When using the gauge, attach it with the excess tube placed in a catch container. Next, attach the gauge to the Schrader valve on the fuel rail and then start the car. This will record the fuel pressure at approximately 40 psi on the fuel pressure gauge. With the car turned off, release the fuel pressure by pushing the button on the side of the pressure gauge. Now you'll be ready to lift the car to check the fuel lines underneath. Once the car has been lifted, test for fuel leaks using a 4-gas analyzer. Using the 4-gas analyzer, check the entire fuel system with the wand from the fuel rail to the fuel tank cap. If a fuel leak is present, the hydrocarbons will increase significantly, verifying the presence of the leak. After the leak has been detected, it'll then need to be fixed.
When troubleshooting with various engine tests, you may need to disable the ignition. Always disconnect the primary side of the ignition. These are the small wires found on the ignition coil that provide the battery power to the ignition system. Never disconnect the secondary coil wire first because a spark could occur. This spark can set off a fire or cause a voltage spike that could ruin the car's computer. To replace or test electric in-tank fuel pumps, never apply a battery voltage to them when they're outside of the tank. If allowed to run dry, they may explode from the fumes.
When doing a compression test to analyze the engine, first disable the primary side of the ignition system to prevent accidental ignition of fuel vapors. Using a screwdriver, secure the throttle linkage to the wide open position after removing all the spark plugs. Next, screw the hose from the compression tester into the spark plug hole and attach the tester to the hose. Make sure the hose is clear of belts and the fan. Crank the engine for about 5 revolutions and read the gauge. Repeat the process for all cylinders.
When working on the engine, there will be times you'll need to remove the engine from the car. An engine hoist can be used for this purpose. To begin the procedure, raise or remove the hood. Next, roll the hoist into the proper position over the car. Adjust the boom so the hook extends to the center of the engine. The further the boom is extended, the less weight it will be able to lift. If the weight is not evenly distributed, the crane could tip forward. To lift the engine, you'll need to secure it with a chain or cable. The chain will then loop around a hook at the end of the boom. Any adjustments that need to be made to the hoist should be done before the engine is attached. Any adjustments made afterwards will mean starting over. Once the engine has been attached to the hoist, you'll be able to move it around the shop. Keep it close to the ground to avoid hitting anyone.
With the engine outside of the vehicle, a mounting stand can be used for support. Be sure to place the stand where you intend to work before attaching the engine to it. Then check the stand thoroughly. Make sure all wheels and fasteners are secure. Once secured, begin working. When removing or tightening the fasteners on the engine, be sure to use the mast or angle side of the stand, which will give you the most support. The mounting stand is on wheels and can be moved if needed. But be careful, the engine is heavy and the stand could tip over.
When working on the transmission system, you may need to remove it from the vehicle. To support the system, a transmission jack can be used. If operated by hydraulics, be sure to check the jack for leaks before using. Also, make sure the wheels and any other fasteners on the stand are tight and in working order. Adjust the arms to fit snugly around the transmission and secure the transmission to the jack with a chain or belt. Transmissions are quite heavy and can have sharp edges. Be careful when handling.
Performing jobs like motor mount replacement requires the engine to be jacked up while the car is in the air. Once the car is raised, you'll need to place a utility stand under the engine for support. Use a spacer of wood or rubber as a buffer between the utility stand and the oil pan, so as not to puncture the pan.
Hydraulic presses are used during transmission work to press bearings. The pressure used is 5,000 to 100,000 pounds psi. Because of this pressure, care should be taken when working around hydraulics. If the bearings were to explode, you or someone else could be seriously injured. When working on differentials and drive shafts, the edges can be sharp. Be aware of fingers getting caught since the parts fit closely together, creating a potentially serious injury if mishandled. Some differential work requires tightening fasteners to around 200 foot-pounds. Remember to pull the torque wrench toward you when doing this to avoid injury.
Now let's review some key points of this program. Before working on the battery or any other part of the car that requires power from the battery, you'll need to disconnect the negative or ground cable side of the battery first.
When servicing the fuel system, any residual pressure will need to be released to assure that any remaining fuel in the lines isn't pressurized. This is important since any remaining fuel or fumes could become a possible hazard.
Once the engine has been attached to the engine hoist, you'll be able to move it around the shop. Keep it close to the ground to avoid hitting anyone.
There are many areas within the automotive shop that demand safety and responsible handling. Using caution and practicing the correct procedures will keep you and others from harm. Don't be careless, be smart. Safety in the auto shop can keep you and others alive.